Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 946 that says validate stack sequences. So guys, in this video we will discuss two approaches to solve this question. One approach will take big O of n space complexity, and further we will optimize the space complexity to big O of 1. So yeah guys, stick till the end and make sure you watch the complete video. So here you are given two integer arrays, push and pop, and each with distinct values, and we need to return true if it is a result of a sequence of a push and pop operation of a stack. Means if it is a valid sequence, and yeah, false otherwise. So currently you might be a bit confused at what is the push and pop operation sequence of a stack. So let me first explain you this with an example. So guys, if you have some stack like this, so sorry, not stack, if you have some elements like this 1 2 3 and 4, and on these elements you need to perform push and pop operation. Okay, so for that let me take one push array and let me take one popped array, and let me take a stack here. Okay, so first element is 1, let me push 1 here. Okay, add 1 here. Okay, let me push 2 here, so adding 2 here. So now after this point what I can do is I can perform pop operation, right? So and then I have only 1 remaining in the stack, so I have popped 2. Then I again push 3, okay, then push 4, so I push 3 and 4, then I do perform pop 3 times until the stack is empty. So 2 4 3 and 1. So guys, this combination of push and pop, this is one combination, right? One combination, or you can say one combination or one sequence of push and pop that is valid. Now guys, for this same elements, what you can do in another ways, so let me again take this push and pop array, and let's say here what you did is you pushed 1, you pushed 2, then you perform pop, and again pop 2 times pop you perform. So let's say you pushed 1 2, you perform pop. So now the array is 2 1, you pushed 3, you perform pop, then you push 4, you perform pop. Okay, so you push 3 and 4, then you perform pop, so it's 3 and 4. So guys, this is another valid sequence, right? This is another valid sequence of push and pop on a stack with these elements. So yeah guys, for a given number of elements there can be multiple valid sequences of push and pop. It's based on how you push an element and when you pop an element. Correct? Got it? So yeah, this some type of sequence like push and pop is given, right? This is a sequence, this is one combination that is given of push and pop, and we need to validate whether the given sequence is a valid or not. So guys, clear till here? Now what is a sequence of push and pop and what we have to do in this question? I hope these things are clear till now. So now to verify whether the given sequence is a correct or not, what we have to do? We have to simply take one stack and perform the operation. Okay, now keep your attention here and keep an eye on how we are performing the operation. So guys, here what we are doing, we are pushed 1 2 3 4 5. So let me push 1 2 3 4. Okay, now after 4, what you can see, the first element that is popped out is 4, as you guys can see, and see there can be only one 4 in the given array. All values are distinct, so there can be only one 4. So what we will do is we will pop out 4, we will pop 4, and after that our stack will contain 1 2 3. Now is the next element after 4 to be popped out is 3? No, it is not 3. So we will continue to push element, we will push 5. Now after push we push 5, we see the second element to be popped out is 5. Correct? That is the at present at the top. See, in a stack, stack follows leaf 4, that is last in first out, so the last element that is added can be removed first. So we are checking the same thing, is the last element or the topmost element of a stack is the element that needs to be popped. Yeah, that this is the element that needs to be popped, so pop this 5. Then you have remaining 1 2 3. Is 3 the next element after 5? Yeah, pop it out, then pop 2, then pop 1. So as you guys can see, after performing this push and pop, our stack is what? Stack is nothing but empty. This is empty, and that means that both combination, means this combination of push and pop is a valid, because we have started from empty stack, we have performed push, and after push we have also performed pop simultaneously, and after doing that our stack is empty. That means it is a valid sequence. So guys, clear till here? Okay, Now let's take a look at the second example. This is going to be a bit interesting. So yeah, let me take one pointer and draw the stack. Okay, so here we will push 1 is 1, and we will also keep an eye what is the first element to be popped. So it is 4, then yeah, it is no, then push 2, the topmost element is not 4, push 3 and 4. Now the topmost element of a stack is the first element to be popped. Okay, then pop it. Now we have stacked something like this, 1 2 3, then push, now check, is 3 the second element, is 3 the element to be popped, pop it out. Now you have something like this in the stack. Now is 2 the element to be popped? No, 2 is not the element to be popped. So what you do, you push 5. Now after pushing 5, you will check, is 5 the topmost element to be popped? Yeah, pop it out. Now you have stacked something like this, 1 2. Now you are here. Now is 1 the topmost element to be popped? No. Okay, then since, as you can see, the topmost element here is 2 and the next element in the sequence of a pop is 1. So at this point you will be never, it is not possible to pop 1. Yeah, you will be never able to pop 1 because of the topmost element is 2, and so the sequence would be 2 and then you can pop 1, right? So the valid pop sequence is 4 3 5 2 and 1, right? 1 and 2, this is invalid sequence. So yeah, that's why we written false here. So guys, clear till here? Understood that how this push and pop will work and how the valid sequence can be identified. This is what we did. This is how we identified whether the given sequence is valid. Okay, so guys, here the approach for the question is simple, that whatever elements we will get in the push, we will try to push. That means push ith element into stack. And second thing to note here is, if s dot top, that means the topmost element of a stack, is equals to jth element of pop array, then perform pop, operation. Okay, clear till here? So let's say if you are given something like this, push arrays 1 2 3 4 5, and let's say pop array is, let's say 3 2 4 5 1, and we need to validate this as a correct sequence or not, then what we would do, as I did a dry run, we will take a stack, we will push 2 and we will check whether the topmost element, see here is our ith pointer and here is our j pointer, we will check whether the topmost element is equal to j pointer. No, then increment your I pointer to here, push 2 and check for this j pointer. We haven't increment j pointer yet, right? Now this 2 and this j pointer, topmost element of a stack, and the j pointer is not same, then again increment the I pointer to here, push 3. So after pushing 3, what you can observe is the topmost element of a stack is equal to j pointer, so you can pop this, right? You can perform this pop operation. So now the stack will be contain 1 2 and increment your j pointer. So after this, what you can see, the topmost element is also equal to the j pointer. Now again you can pop this element, so pop it. Now you have 1. Now is 1 equal to this j pointer? No, then increment your I, add 4, again there it is equal, so perform pop. Now you have only 1. Now the j pointer is here at 5. Is it equals to this? No, then increment your I and add the element. Yeah, now it is same, this topmost element is same to the j pointer, pop it. Now the topmost element is again same to the j pointer, pop it. So now this stack is empty. So this, since the stack is empty, we can say that the given sequence of push and pop is a valid sequence. Okay, so this is how we are using a stack and performing the push and pop operation, we will solve this question. So guys, I hope the approach to solve this question is now clear. Okay, so the code is now simple. Take one stack, here we took n as the size of this push array. Now we took 2 pointers I and j, and we check, and we push the ith element to our stack. Then we ran a while loop and we check whether the topmost element of a stack is equal to the jth pointer. If it is there, then pop that element. If the next topmost element is equal to the jth pointer, the pop out the element and increment the j, right? And yeah, we will do this until the size of a stack is greater than 0 and until j is less than n. So these are some of the base condition for this while loop. and then at the end we check whether the stack dot size is equal to 0. That means whether the stack is empty or not. If it is empty, then we will return true, else we will return false. So I hope the code is now clear. The code is the same that we are doing here. This is the dry run of the ith and j pointer we did. Now guys, talking about the time and space complexity. The time complexity here is big of n, and the space complexity here is also big of n, because we are storing all the n elements to the stack, right? And also you can debate that time complexity is not just big of n, it is big of n plus n, because we are traversing this pushed array as well as popped array. So it is n plus n, but overall you can write it big of n. Okay. Now can you optimize this solution? Yeah, we can definitely optimize this solution by using 2 pointers. So overall also we were using these 2 pointers only in this solution, that is the ith pointer and the jth pointer. The same thing we would do in this solution. Okay. So for that, let me take one sequence again. For a dry run of this solution, let me take one push sequence 1, 2, 3. Okay, so here now instead of using the stack, what we will do, we would keep changing the value or the topmost value in this pushed array itself. See, instead of using the stack and checking for this topmost value, we would use this pushed array. So we would so that would reduce the space complexity. Let me show you. So we have initialized ith pointer to 0, jth pointer to 0. Now we are traversing all the elements of this pushed array. Okay, with the help of x, we are just marking push of I equal to x. So that means here initially I, again let me take this pushed array. Here I is 0, initially I is 0, and we are marking push of I equal to x. So x is 1. Okay, so yeah, this thing we are doing. Let me take this whole. Okay, so currently I is here. Okay, I is here, and we are just making push of I equal to x. We are incrementing to I. So now I is this point. I is at 1. Okay, now after that, this while loop is the same. This while loop is the same, that j is less than n. So instead of s dot size greater than 0, what we are doing? We are doing I greater than 0, and we are checking a topmost element that is present at I minus 1 index. Okay, if that index is equal to pop.j, the same condition we are checking, then what we are simply doing, so instead of s dot pop, we are simply decrementing our I pointer and incrementing j pointer. So this is the code. Now currently here our I minus 1 is what? Element is 1, and our j pointer is what? J pointer is 3. Whether they are same? No. Then what we are doing? This for loop, this while loop, we are not entering while loop right now, and we are just making a call for the for loop. Again, what we are doing? Push to 5. That means at index 1, we are passing the value 2. So this value remains as it is 2. Okay, and we are incrementing I2 here. So now is this I minus 1, that is this element, is equal to this topmost element j. J is here. Okay, see, j is at the index 0, and this element 3. If it is equal, this 2 and 3 equal, no. Then again run a for loop, mark push to 5 equal to x. That means at this index we are marking 3 value, so the value will remain the same. Increment the I2 here. I will, after this point, I will point to index 3. So now here I minus 1 is there. Now this I minus 1 equal to j, this condition is hit. I minus 1 is equal to j. Then in that condition, what we will do, we will decrement this I. So after here, our I will again move to here. So now I value will become 2. Okay, got it? We were decrementing the I and incrementing the j. Now the j will point here. Now is 2 equal to again I minus 1. So current I is 2. Now it is equal to the previous. Yeah, it is then. Then again decrement I from here to here, and increment j to here. Okay, so yeah, now j is here and I is here, and at this point what now this while loop will finish, because I minus 1 is 1, j is 5. This condition is not satisfied, so we will loop the for loop ahead. Okay, now looping the for loop ahead, what we will push, our I is what? I is at index 1. So at index 1 we will push x. So our new push array would be 1, 4. Got it? it would be 1 comma 4, right? 4 comma 3 comma 4 comma 5. This would be our new pushed array at this point, that we are pushing. Our I pointer would be here, so here we will push this 4, element 4, and that after that we will increment our I to here. Okay, got it? Now is the I minus 1, that is element 4, is equal to popped of j, that is 5. No, this 4 and 5 are not equal. Then run a for loop. So our I pointer is here, so at that point add 5 here. So instead of 3 we will push what? We will change its value to 5. That is what we are doing. Pushed of I equal to x, so x value is 5. So here change the value at I pointer to 5 and increment I to here. Now I minus 1, that is this, is equal to j. Yeah, 5 is equal to 5. Then simply do I minus minus j plus plus. So now the I minus minus would be here, I would be again here, and I minus minus will point to 4. Now this 4 is equal to this j. Yeah, they both are equal. Then again perform I minus minus. Here I will come to here at index this. Now I minus 1, this is equal to j, this one. Yeah, they both are equal. See, they both are equal. So then now decrement I to here, that is the 0th index. So at this point I would become what? 0. Now since I is not greater than 0, this while loop will end. This for loop will also end because there are no elements remaining in this pushed. So yeah, at the end we would check whether I is equal to 0 or not, then we will return true as false. So guys, this approach, this two pointed approach, is almost similar to the stack. The only thing we are doing is we are using in place solution. That means we are simply changing this given pushed array in such a way that the topmost element will act like a stack. It will act like a stack, and by checking I minus 1 we will get the topmost element of a stack. We are simply doing this thing, correct? And yeah, we have to update based on the I value. We have to update the value of this pushed array like to 4 to 5 at in ith index, right? So yeah, we try to replicate the stack functionality in the pushed array itself by incrementing and decrementing the ith pointer, and yeah, other apart from that, the j pointer and the popped array, the same other logic remain the same. So the time complexity here would be the same. Time complexity would be here the big O of 2n, but the space complexity here is reduced to big O of 1, as we are not storing anything. We are simply using 2 pointers I and j. So yeah guys, this is, you can say, a very much efficient approach to the to this solution. So yeah guys, that's all for this video. If you guys have any doubt, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.